Let's do an application problem that involves decimals. I have one here. Let's look at this one. Carol's parents added on to their house, and they had an exercise room built next to her bedroom. The area of the exercise room is 32 square meters. If the length is 5 meters, what's the width of the exercise room? I want to go back over it and look to see what the facts are. Carol's parents, they added to the house and they built an exercise room. And they built it right next to Carol's room. That's neat. I wish I had that when I was growing up. The area of the exercise room is 32 square meters. If the length is 5 meters, what's the width? Well, I'm going to assume that this exercise room is a rectangle. So I'm going to draw a rectangle. And they're saying the area is 32 square meters. So I'm going to say A equals 32 square meters. That's the area. If the length is 5 meters, I'm going to make this the length. They want to know what's the width. What is W? Well, we know from previous courses that the formula for the area of a rectangle is length times width. Or we could say length times width, either one, equals the area. What are we given? We're given the length. So I'm going to go ahead and use this equation. It doesn't matter. The length is 5. And we also know the area, which is 32 square meters. But we don't know the width. Look at this. We have an equation. We're needing to solve for W, which is the width. What do we know when we're solving decimal equations that involve a variable? We use the inverse operation. This says 5 times W. What's the inverse of multiplication? Division. So what are we going to do? We're going to divide both sides by 5. And what are we going to end up with? 5 divided by 5, of course, is 1. So we have W equals, now let's come over here and divide 5 into 32. It'll go 6 times, which is 30. 2 left over. I'm going to go ahead and I'm going to add a decimal point and extend it one place. If I add a decimal point, I'm going to have to put 1 in the quotient. And I'm going to bring it down. How many 5s are in 20? 4. 4 times 5 is 20. Notice the width turns out to be 6 4/10. And that's what we were trying to find. So the width is 6 4/10 meters. And the length is 5 meters. And if we checked it, we would find that 5, the length, times the width, 5 times 6 4/10 will equal 32 square meters. Let's take a look at a second part to that equation, to that problem at least. Carol's parents, remember, we just worked the problem where we knew the area of the exercise room, we found the length, and we found the width. Now they're wanting to carpet the exercise room. Let's read the problem. Carol's parents, they want to carpet the exercise room. The price of the carpet is $18.75 per square meter. What's the total cost to carpet the exercise room? Okay, we found the area, or at least we were given the area. Let's see if we can set up an equation. We're wanting to find the total cost to carpet. So the total cost will equal the area, which we found, the area times the cost per square meter. Okay, let's substitute. From the previous problem, the area was 32 square meters. And now we see that the cost per square meters is $18.75 per square meter. What's the total? Well, I'm going to come over and I'm going to multiply, because it says multiplication. $18.75 times 32. 2 times 5 is 10, 14, 15, 16, 17. 2 times 8 is 16, and 1 more is 17. And 2 times 1 is 2, and 1 is 3. Now we need to multiply by the 3. 3 times 5 is 15. 3 times 7 is 21, and 1 more is 22. Make this a 2. 3 times 8 is 24, and 2 more is 26. 3 times 1 is 3, and 2 more is 5. Now let's add. 0, 0, 7, 8, and 2 is 10. 1 and 3 is 4, and 6 is 10. 5 and 1 is 6. Now we're not quite through. Remember, when you're multiplying decimals, you have to, how many places are to the right of the decimal point? In the first number, there are 2 places. How many to the right of the second number? 0. And we have to have a total of 2 places in our product. 1, 2, and remember, this is money. So what is the total cost to carpet the exercise room? We found it to be $600. That equals the total cost. Okay. Once again, solving decimal equations is very similar to solving equations that contain whole numbers. You just need to remember using the inverse operations to get the variable along on one side of the equation. And then you'll get it right.